Hi everyone. Today we are going to do RLC circuits and study about resonance. R represents resistance measured in ohms. L represents inductance measured in Henry. C represents capacitance measured in farads. Today for performing the experiments we need the following components. We need a 10 kilo ohm resistor marked with brown, black, orange, gold bands, a 4 Henry coil which is going to serve as your inductor, 0.01 microfarad capacitor. This is going to be numbered as 103. I shall later talk about how 103 is equivalent to 0.01 microfarad capacitance. Therefore, for today we are going to use some jumper cables, breadboard, few hookup wires, 4 Henry coil, together it is 4 Henry, so 4 Henry coil, 10 kilo ohm resistance and 0.01 microfarad capacitor. Now, this reads 103. This is 0.01 microfarad. Look at this, guys. 103 can be written as 103 is the multiplier, so it is 10 raised to the power 3. When the capacitors are numbered like this, we should consider them in picofarads. Their rating is in picofarads. So I have just written 10, and 10 raised to the power 3 is done with 3 zeros, picofarads. Now 10,000 decimal point is here. I have written 10 picofarad is 10 raised to the power minus 12. I have just written it like this for convenience. Now I am going to move this decimal point 6 places to the left, and I would have it in 10 raised to the power minus 6 farads like this. The decimal point has moved 6 places and it is here now. Now 0.01, and there is only one 10 raised to the power minus 6 farad, so I can say it as 0.01 microfarads. Hi guys, this is RLC meter with which we are going to measure our resistance, capacitance and inductance values. First I am going to measure the resistance. The power button for this device is here. Switch it on and click R, which is for measuring the resistance. Now this is my resistor. I shall put it between these ends. Now I have to select the range. It is in kilo ohms. Actually I have taken 10 kilo ohm resistance, so I am going to set in kilo ohms range for measuring. The display reads 9.98 kilo ohms. I can approximate it to 10 kilo ohms. Next would be to measure my capacitance value. This is my capacitor. 103 is marked on the casing. Now I shall just fix it here and show you how it is measuring 0.01 microfarad capacitance. I have to select capacitance and I fix here and see how much does it show. It is in microfarad. I want 0.01 microfarad. It shows 0.009. I can approximate it to 0.01. Next is my inductance. Hi guys, this is my inductance. I am going to use two inductances connected in series to get 4 Henry. I am connecting it here. I am connecting the ends like this, and I am going to fix across these 2 points and check if it measures 4 Henry. It is showing 4.26. I would approximate it as 4 Henry. Now all my components are measured. I'm going to record them in my table. I'm going to note the 10 kilo ohm resistance value here. It showed me 9.98 kilo ohm, and 4 Henry coil showed me 4.24 Henry. Zero error of the DMM is to be measured. Now I am going to take the terminals of the DMM, which are here. Here are the terminals of the DMM. I have to set in ohms mode, and I have to connect the positive and negative together to measure the zero error of the meter. It is showing me 0.69 and 0.70. I would consider it as 0.7 ohms resistance for zero error, and I have to note it here. Ohms. Now we are going to hook up this circuit. With an inductor, resistor and capacitor. 4 Henry inductance should be connected in series with the resistance 10 kilo ohm with 0.01 microfarad capacitor. All these series components should be connected across the function generator supplying 5 volts RMS. Initial frequency setting is 500 Hz. We are going up to 1500 Hz in steps of 50 Hz to identify the voltage drop across R1. The voltmeter should be set in AC mode by clicking on this button. Now I am going to set the function generator to 5 volts RMS, 500 Hz frequency. Power button is here. I am clicking on, and I am going to set the frequency at frequency. I click on frequency, and it is showing me 1 kilohertz, but I am going to set at 500 Hz, and the amplitude is showing 4 volts PPP, but I am going to set it at 5 volts RMS. Now amplitude, this is highlighted. Now I would click on 5.0, and volt RMS is here. I click on. Now 5 volt RMS 500 Hz frequency is supplied by this source. Now channel 1 is my output. I click on channel 1 output. I am going to connect it to the circuit. Now I am going to first hook up the circuit on my breadboard. Here is my breadboard. I am going to connect the inductor first. Here the terminals of the inductor are connected. Here is one end, the other end is here, and these two ends are connected together. As you know, they are connected in series. Now check if the connection is okay. Now next is your resistor that has to go in line with this. Do you see? They are in the same line for getting the series connection. Now is the capacitor that should go in line with the second end of the resistor like this. Now all the three components are connected in series. Now I am going to use some hookup wires to connect to the second end of the capacitor and the first end of the inductor so that I could connect it to the function generator. See, I have connected a wire for connecting to the negative of the supply in the same point or in the same line as the second end of the capacitor, and a red wire to connect to the positive of the supply. Here are the ends of my function generator. See, the function generator inputs are here. I am going to connect positive to the first end of the inductor and negative to the second end of the capacitor. Now my connections are done. Now the pending connection is to the DMM. One end of the resistor gets the positive end of the DMM and the second end of the resistor gets the negative end of the DMM. Now I am going to connect red connection probe to positive and black connection probe to negative. See, the negative goes to negative, positive goes to positive here, and without disturbing the connections, look at the DMM reading now. It shows me 1.59 volts. I am going to record these values in the table. See, I am just going to strike up to 450 Hertz. I am not going to do it. I am starting at 500 Hertz. Trial 1 is showing me 1.59 volts on the DMM. So 1.59 volts. Now I am going to set the function generator frequency to 600 Hertz. 550 Hertz. 550 Hertz, and I am going to see the DMM reading. It shows me 1.82 volts. 1.82 volts. I would continue for all the frequencies in steps of 50 Hertz, 600, 650, 700, 750, 800, 850, 900, 950, 1000, 1050, 1100. I am cancelling 1150 to 1500. I don't need these readings because resonance is going to take place within these frequency ranges. See, I have recorded the values already. I have noted from 500 to 1100 Hertz, and the values are like this. It increases up to a certain value and starts decreasing. In the second trial also it has happened the same way. Up to certain voltage it is increasing, and after that it is decreasing. Now is parallel resonance. The previously done circuit, that is 3 of them connected in series, is for series resonance. Now is parallel resonance. Now what I am going to do is I am just going to take away my DMM terminals for a moment, connect the resistor. Now I am going to take out the capacitor, connect it across the inductor. See, I have connected it, and this point is not connected anywhere. Now with a small hookup wire I am going to connect this end to this, the other end of the inductor here. Now the inductor and the capacitor are connected in parallel and resistor is here. The second end of the resistor gets the power supply negative. Again, the ends of the DMM. Now I have connected the capacitor in parallel with the inductor, and I have connected the DMM across the resistor as it was before. Now I'm going to again start at 500 Hertz frequency to record the values. I'm going to start setting my frequency at 500 Hertz for the parallel resonance. Check if the RMS voltage is showing 5 volts. Now 500 Hertz. Now look at the DMM value, 1.25 volts. I would record it in the table. I'm going to record the value in parallel resonance, 1.25 volts, and again I would set the frequency to 5. Next, set the frequency to 550 Hertz. 50 Hertz. Note the value from the DMM, 1.01 volts. 1.01 volts, and continue recording the values up to 1100 Hertz. I have done it already. 1, 2, 3. The values are recorded here. The values just keep decreasing up to a point and start increasing. I have done 2 trials. The values are decreasing up to that same point as before, and from there it keeps increasing. Note down the values, and you're going to plot a graph for series resonance and for parallel resonance. The frequencies are taken in the x-axis and the voltage across R1 in the y-axis. The frequencies are taken in the x-axis. Voltage across R1 is taken in the y-axis. The frequencies are taken in the x-axis. Voltage across R1 is taken in the y-axis. For series resonance, the values keep increasing up to a point and it starts decreasing. You get a bell curve. An inverted bell curve is obtained when you connect the capacitor and inductor in parallel. The values keep decreasing up to a point and start increasing. You would see practically at what frequency this happens, and I shall teach you in theory how to get this resonant frequency. Thank you for watching. All the best.